In this lecture, we're going to be going over the basic anatomy of a small Node application. This is not a building exercise. There's no need for you to write this small application yourself. But if you want the code, you can download it from the link on your screen. This application is just a super small example to familiarize yourself passively with the structure of a Node app. We'll be going over all this stuff again as you build your own apps in the following lectures. First, let's start with an empty directory. This is where the app is going to live. This is where we're going to put the primary JavaScript file for this application, whose name we will pass to node.js in order to start the app. We can call it anything we want. In this example, we've called it index.js. So when we run this application, we'll do so by calling node index.js from within the base directory. In other words, within our terminal, we'll cd, change directory, until we are inside of the base directory, and then we'll enter that command. If we entered that command within a different directory, we would likely need to provide a relative or absolute path to index.js, so Node would know which file we're actually talking about. When we're inside of the base directory, Node is going to look for the file called index.js in that directory automatically. Inside of this index.js file, we can see a few sections: comments, dependencies, module scaffolding and configuration, function declarations, and function invocation. We're going to take a roundabout way, but we'll eventually look at each of these sections in more detail. First, upper comment block. These are pretty self-explanatory. I'm giving the file a title as well as a lengthier description, and I'm also using one of the much derided conventions of stating the author and date within the comments as well. You'll find a lot of developers who hate this tradition today and find git commits to be a much more expressive way of conveying who has added what to which file and when. But for this example, I've just hard-coded in my name and the date. Dependencies. The logic contained further down in the file is based on having certain variables such as mathlib and certain functions such as mathlib.getRandomNumber defined. We don't define these ourselves. Instead, we require or import an external file and assign the contents of that file to a variable. Or more accurately, that imported module has exported a certain object or interface, and the interface it is exporting becomes available to us at the variable we assign to it. So in our example, we require a library that lives at .lib/math.js, and we assign it to the variable mathlib. At this point, everything that the math.js library has decided to export has become available to us within that mathlib variable. Before we move on, let's open up lib/math.js and see what's going on inside. This file is very small. There are some comments, then an object is created, a function is added as a key to that object, and finally that object is exported using the module.exports convention. To put it another way, an object is defined and then exported to whatever file has decided to require or import this module. This includes the getRandomNumber key that was on the object. So back to index.js. We import the math library, assign it to the mathlib variable. Then further down, you can see that we use math.js's getRandomNumber function, and that we do it by calling the getRandomNumber key on the mathlib variable we assigned to the object when we imported it. Note, however, that the top variable name, to which getRandomNumber is a key, is arbitrary. We could have just as easily imported the math.js library and assigned it to a variable called coconut. And then in that case, we would call getRandomNumber by invoking coconut.getRandomNumber instead of mathlib.getRandomNumber. The keys that math.js define are always available to us as they were defined in that file, but the variable object that contains them can be named anything we want. But hold on, you might be saying, we didn't import lib/math.js, we only imported lib/math without any file extension. So how come math.js with the .js extension got imported? Well, that's just a convenience that Node provides us. When you try to import something, it assumes that you're either importing that file name with .js at the end, or that you're importing a folder of that name, and that folder contains a file called index.js. In that case, we will import the index.js file within that folder. This is exactly how the next line works. You'll see it's importing /lib/jokes and assigning it to the variable jokeslib. But if you open up the lib directory, you won't see a jokes.js file. You'll see a jokes directory, which has an index.js file inside of it. Node is smart enough to know that you intend to import the index.js file within the jokes directory, and all you have to specify is the location of the directory itself. Let's open up the index.js file within the lib/jokes directory and see what's inside. The first thing you'll notice after the obligatory comments is that this module is also requiring something else. It's important to point out, though, that variables such as fs that are defined within this module are scoped to this module and this module alone. You'll notice that the jokes object gets created, a key gets added to it, and then it gets exported. But fs is not defined as a key on that object, so it's not one of the things that gets exported. But if you look closely, you'll see that a function defined within fs gets used within the all_jokes function on this module. So you might be asking, if fs never gets exported, won't this function break if another file requires this one and then tries to call the all_jokes function? No, it won't break. This is another quirk of how Node scopes variables. You don't need to export fs. It's the node.js equivalent of a private object or function within the module and is only used internally to that module. If, however, the file that requires this one wants to use fs, then that file will need to require it on its own. Either that or this file will need to export it directly to that one. I'm sure all of this can seem a bit confusing, but it will make more and more intuitive sense over time and with repetition. We'll be dealing with this issue a lot. Now let's browse through the repo and try to find this fs library that this file is importing and using. Oops, it's not there. Is this an oversight? No, it's not there because fs is a module that comes standard with Node.js as part of their API. You don't need to download fs or write it yourself, but you do still need to require or import it and assign it to a variable if you want to use it. Over the course of this lecture series, we'll be building our applications with many native Node.js modules, as opposed to third-party NPM modules, so you'll become very acquainted with these over time. Now, what does this Node application do? Before we look in detail, let's just run it and see. If you've downloaded the code earlier, just cd into the directory and type node index.js, then press return. At this point, you should be seeing a new joke printed to your console once every second. Now you can kill the program. In OS X, just hold down the control key and press the letter C. Other platforms will differ. So we can see that this is a pretty ridiculous program. It just tells us random, terrible jokes one at a time. And sometimes, due to random chance, it repeats jokes twice in a row. Now that we understand the purpose, let's go back to the primary index.js file in the base directory. We've covered what the comments and dependencies do, so let's move down from there. We can see that this file is also built as an object and has keys added to it. This isn't for any particular reason, but I find that using this kind of object literal notation, OLN, for all my files keeps things cleaner and makes testing easier later on. The first subkey that gets defined is a config key, and within that object, we define a time between jokes variable that we can use later by accessing the app.config.timebetweenjokes key. If we keep scrolling down, we can see that we define two functions. One that prints a random joke to the console, and one that loops indefinitely, calling the first function over and over and over. Let's look at the first function. First, it invokes the all_jokes function that is part of the jokes library and assigns the return value to a variable. What's the return value? Let's look at lib/jokes/index.js again. Here we can see that this function simply reads in the content of a jokes.txt file from the file system, splits the content into an array, and then returns the result to the caller. If we open up the jokes directory, we can see the jokes.txt file that it reads in. Now, back to the main index.js file in the root directory. At this point, the function we were looking at has imported that array of jokes and assigned it to an all-jokes variable. Then it gets the length of that array and assigns that length to the variable number of jokes. Now it needs to pick a random joke out of this array of jokes. So it gets a random number between 1 and however many jokes were in that array. It does that by passing 1 and the number of jokes variable to the getRandomNumber function that is defined within the math.js library, which has been assigned to the mathlib variable. So it calls mathlib.getRandomNumber between 1 and the length of the joke array, and the resulting random number gets assigned to the variable random number. Now, we can see that this script wants to get the nth joke of the joke array, effectively getting a random joke. But since arrays in JavaScript start with the position called 0, not 1, we would need to actually get the joke at the nth minus 1 position, not the nth position. That way we have a chance of getting the 0th joke, and we don't run the risk of asking for a joke at a position that is 1 greater than the maximum position in the array. We select the random joke and assign it to the variable selectedJoke, and then we log selectedJoke to the console. So in a nutshell, this function uses the two libraries required at the top to get all the available jokes, select a random item from the set of jokes, and then log that joke to the console. Now let's look at the other function, app.indefiniteLoop. This one seems simple enough. All it does is create an interval that calls the first function above and does that after every x milliseconds, where x is whatever number is set in the config object defined at the top of the file. Once this function is called, the print-a-joke function will be called over and over again, indefinitely. And as we learned earlier, in this example, at all times, the node.js event loop will always have something left to do on its to-do list. In this case, it will always have another print-a-joke function to call in the future, and therefore this node app will never exit unless some kind of error occurs. Now, at this point, all we've done is define two functions. So when node.js starts and reads this file, it will see those functions defined, but it won't call them. It will read in the dependencies since they are defined in the tree, but the app won't actually start running because nothing explicitly started the app. That is left up to the final line that actually invokes the looping function. All it does is call that function, which in turn calls the other one once every x milliseconds, 1,000 milliseconds, aka 1 second in this case. To illustrate this, let's comment out the last line so that nobody explicitly calls any functions. Now let's start the app. As you can see, it returns you right back to the command prompt and doesn't seem to have done anything at all. In fact, it did do something. It read in the dependencies, it pulled the function definitions into memory, it started up the event loop, but then there wasn't any synchronous code to actually invoke these functions, so nobody lit the proverbial match. Nothing got the ball rolling. After starting the event loop, it saw it had nothing left to do, and nothing to do in the future, so it exited, all within a split second. Alright, that in a nutshell is a Node application. Really, it's more complicated than it needs to be, but I wanted to show you how require statements work. In practice, however, practically every Node.js application you encounter in the wild is going to be more complicated than this. Most will contain more files, like a package.json that we didn't include here. So in the next section, we're going to go over many of the common Node.js conventions you'll find out in the wild, from file structure to coding patterns. We may or may not be using these conventions later on in this course, but it'll be worth it to go over them so you can better understand any random Node app that you may encounter.